Class example 2.2.3, multiply and then combine like terms. Now, before we get going here, that instruction verb that says multiply here, that's the action that we're trying to do. I've mentioned this before, but multiply is the same thing as expand. So this could say expand and then combine like terms. So those are the same things. It could also say determine the product and collect like terms. So determining the product, multiplying these sets of brackets out, or expanding, they're all synonymous. The next thing I want to see is we got a lot going on here. Now, I see I first have x plus 3 multiplied by 5x minus 2. And then I'm adding 4 multiplied by x minus 1, 2x plus 5. Now, I emphasize the and then because there is an order of operations. I'm sure you have all seen this before. An acronym for brackets, exponents, division and multiplication, and then addition and subtraction. Multiplication has to come before addition as well as subtraction. So we need to make sure that we know that multiplying or expanding these two blocked off terms has to happen before we can actually do any addition. You can't add these together until they've actually been expanded and your brackets are gone. So we're going to have a lot of terms here, but that's okay. We'll work through it nice and slow. I'm going to stick with the distributive property for question A, and then I'll use the claw method or the FOIL method for question B. So I'm going to write this a little bit differently this time. In my distributive property, this time I'm going to break apart that first term as x plus 3. So we've done it where we've broken apart the second term when we had a nice set of brackets. We've done that with when we had a trinomial behind. It doesn't matter how you break it apart, as long as everything in one set of brackets gets multiplied by the other. So I'm going to distribute that 5x minus 2 to both of those two terms. Okay. Now I'm just going to change my ink color so that we can really overemphasize that this next step is separated. Okay. Now we have options here. Okay, we know that 2 multiplied by 3 is the same thing as saying 3 multiplied by 2. Okay, we know that for sure. We also know that, I don't know, let's say 3 times 2 times 4 is the same thing as 3 times 4 times 2, which happens to be 2 times 4 times 3, or maybe 2 times 3 times 4. These are all going to equal to the same thing. There's a couple more combinations. The point is we know that when we multiply things together, it doesn't matter what order we multiply them in. So when we look at this second blocked off term, which was 4 multiplied by x minus 1 multiplied by 2x plus 5, I can multiply it in any order I want. I can multiply the first and the second. I can multiply the first and the third. I can multiply anything I want. So I'm actually going to distribute that 4 into the x minus 1 first, which is going to be, and notice I've got brackets still here, 4x minus 4. And then I can still actually go ahead and multiply this 2x plus 5. Now, you could have done this and said 4x minus 1 times 2x plus 5. We could have actually said, no, forget it. Let's multiply it by the other term and say that that's 8x plus 20. And then multiply these together. It'll come out to the same answer either way. I just like to go in the simplest way as possible. The 4x minus 4, these guys being combined, seem the easiest. So let's move on or go back to our first term now that we've kind of applied some things to it. All right, now I'm going to take my distributive property and take x times 5x, that's 5x squared. X times negative 2 is negative 2x. I get positive 3 times 5x is 15x, and positive 3 times negative 2 is negative 6. I'm not collecting any like terms yet. I'm hoping you've noticed that all I'm doing right now is dealing with one term and now the other. Okay. This one, the second term is taking a little bit longer, isn't it? It's because we had 3 going on and we only had 2 here. So now I'm going to take 4x minus 4 and distribute 2x plus 5 to both those two terms. That's my next line. Okay. I'm going to actually just keep going. I've got my nice red pen going already. So I'm going to distribute this to be 8x squared plus 20x. Ironically, that's right here. Minus 8x plus 20. Oh, that kind of makes sense, doesn't it? If I would have done it this way. All right, and I'll rewrite my blue section as 5x squared minus 2x plus 15x minus 6. Okay, the multiplications are done. We can see that there's no sets of brackets in between any of these terms. I see that they've been separated with this bright red plus sign, but now it doesn't matter what order we add or subtract these in as long as we are collecting like terms. So in our collecting of like terms, we may have 2 or 3 different things going on. We may have 1, who knows? Right now I'm going to look for x squared terms. So I have a 5x squared, there's an x and x. Oh, I got a positive 8x squared, and it doesn't look like anything else, so I'm going to collect those two. 5x plus 8x is going to equal to 13x squared. Okay. Next I can see I've got a negative 2x, a positive 15x. I have a positive 20x and a negative 8x, so I'm going to add and subtract all those together. Negative 2x plus 15x is 13x. 13x plus 20x is going to be 33x. And 33x minus 8x is going to equal to 33 minus 8 is 25x, all nice and positive. So I get 25x going on. I see I've got a minus 6 and a positive 20, so I'm going to be left with a 14 as my constant left over. So you can see there's a lot more terms going on. There's a lot more work, but it's not difficult work. So all you have to do when you're doing this is be slow and systematic, because human error is the hard part here. You know, sometimes people say 4x multiplied by 2x is 6x squared. Like, that's a common one, right? Because you're like, am I adding? Am I multiplying? That's why we like to separate them. Okay, for question B, I am going to use the claw method. 2 multiplied by 3x and then 2 multiplied by negative 2. Now, I've got that subtraction sign in between those two, so it's almost like I want to just separate those two, and I'm going to just deal with these two binomials first. I'm going to say with the claw 4x times 2x and 4x times negative 5, 7 times 2x and 7 times negative 5. Now, I'm going to have to be cautious about my negative sign in here, so let's just start with the one. 2 times 3x is going to be 6x, and 2 times negative 2 is going to be negative 4. I'm going to put a big subtraction sign here, and then I'm going to open up a set of brackets. Now, within this set of brackets, I'm going to expand this out like I normally did, right? 4x times 2x is 8x squared. 4x times negative 5 is negative 20x. 7 times 2x is 14x. And 7 times 5 is negative 35. And then I will close that set of brackets. Okay, we've seen this 3 times now. This is our 3rd time where we have to deal with that negative sign in front of a set of brackets. You have choices. Okay, now I like to get rid of the brackets first. Some people like to combine some like terms within the brackets first. It's up to you. I'm going to leave this right now as 6x minus 4. Then I'm going to say that all the terms on the inside of that set of brackets will change symbols from negative to positive or positive to negative, because it's like I'm multiplying everything on the inside of this set of brackets by negative 1. But now at least I see that my brackets are gone. I don't have to worry about any more multiplications. They're all done. All I have to do now is collect my like terms. Okay. Now when we're collecting like terms here, notice that everything we've done so far has gone in what we call descending order. So the highest power was first. It was to the power of 3, then to the power of 2, then to the power of 1, and so on. This one starts with a 6 and an x. There's no x squared, but down the line I see an x squared. So what we'll do is let's combine the like terms first. I have a 6x, I have a positive 20x, I have a negative 14x. Okay, so if I take 6x plus 20x, I get 26x. And 26x minus 14x is going to equal to positive 12x. Next, I have a constant of negative 4 and 35. So if I have negative 4 plus 35, I'm going to get 31. It's just a constant. And then I have this negative x squared who doesn't have any partners. This technically is a correct answer, but in English, you start your sentence with a capital letter and you end it with a period or exclamation point or something along those lines. The same thing happens in math. We tend to have conventions. So what we're going to do is we're going to rearrange this so that it goes into descending order. So my highest power happens to be x squared, and the coefficient in front of that is negative 8. So I'm going to rewrite this as negative 8x squared plus 12x, and then I write my constant at the end. When we get into higher levels of math, it makes sense as to why we do this. For now, it's just a rearranging into descending order as convention.